Hello everyone, my name is Kelsey Cameron, and today I will be talking about how the congestion window works within TCP, why it's important, and the mathematical algorithms behind it and the reasons for them. So first of all, I'm going to explain what is a congestion window. Well, a congestion window basically tells is an agreed upon number for the sender and receiver for the amount of packets that can be transmitted over a network. So CW, congestion window, will start at 1. And that means that one packet can be transferred over the network and then one acknowledgement is sent back. Whenever the acknowledgement is sent back, then that congestion window is allowed to increase. So first you have what is called slow start. The reason it's called slow start is because you start at 1 and you double every single time. So every time you get another acknowledgement, you double it. So first here, CW is equal to 1. You got an acknowledgement back. Great. Okay, you double it. Now my congestion window is 2. 2 packets are sent out. 2 acknowledgements are received. Great. Double it. Then your congestion window is set to 4. 4 packets sent out. 4 acknowledgements received. Great. Double it. 8 packets are sent out. And there is a timeout. That means that there was presumably a problem in the network where the timer timed out and the acknowledgement didn't come back, which can be a sign of network congestion. So if you know that you have if you have too many packets in your network and it's causing congestion, well, you want to basically start over. You want to see, okay, what is the max congestion I can get to again? You really don't want to keep overloading the network, and that's why this algorithm is the way that it is. Because if you were to do anything else, then your number for the congestion window could still be too large, and you also want to give the network a chance to recover, and that takes time. So as soon as there's a timeout, you set the congestion window back to 1. So here the congestion window is 1 again. And every time the congestion window is set to 1, that means that you are using slow start and you double it each time. Double each time. So we do it again. So our congestion window is equal to 1. 1 packet sent out, 1 acknowledgement received. Awesome, double it. Now we're at 2. 2 packets are sent out, 2 packets are received. Awesome, double it. Now we're up to 4. And when we get to 4, there's a 3 duplicate ACK. That means that most likely the network itself is fine, but somehow one of the packets that we were sending the acknowledgement, it just screwed up. Basically, one of the packets didn't send correctly. Maybe the data was corrupted. Maybe it's wireless interference. So that had to be resent, and there was a 3 duplicate ACK. So when there's a 3 duplicate ACK, in order to give the network a chance to resend that, when this happens, I mentioned something in another video called fast retransmit. That's where the timer is completely ignored, basically, and whatever ACK keeps coming back, whatever that sequence number is, it's immediately retransmitted without waiting for the timer to time out. But you want to clear up the network a little bit for that. So whenever you get a 3 duplicate ACK, you have the congestion window. You divide it by 2. So when you divide that by 2, now we're back to a congestion window of 2. That fast retransmit occurs, and then the packet sends successfully. But once that happens, you start to increase linearly. You do that because it's similar to the cumulative ACK. You know that the network is still pretty good, but you don't want to overload it. And that's why we're not using exponential increase anymore, like slow start. We're not using that anymore because we know that the network is already good. And if we don't want to increase it too much, or it could cause too much congestion. So we're going to just increase the congestion window linearly. So after we have to the network, we start increasing linearly. So now 2 packets are sent out, 2 acknowledgements are received. Great, add 1. 3 packets are sent out, 3 packets are received. Great, add 1. 4 packets are sent out, 4 packets are received. Great, add 1. 5 packets sent out, 5 packets received. Awesome, add 1. And you keep going. And then either this would continue in the line, or if there was a loss, let's say there's a loss here, what do? Well, you set the congestion window back to 1, and then you do slow start again. So slow start only happens when the congestion window is equal to 1. If you have and that's only for a loss or a timeout. Timeout presumably means loss. So, and then if you have a 3 duplicate ACK scenario, then you have to have the congestion window. So CW divided by 2. Hopefully that makes sense to you guys, and let me know if you have any questions. This is a rather short video because it's a pretty straightforward topic. I hope you enjoy it, and I hope you have a wonderful